Hello, dear listeners. Welcome to Semaphore Uncut, a podcast for developers about building great products. In this new episode, our host Darko welcomes Solutions Engineer Adib Saikali. Adib shares his experience in cybersecurity to adopt CI pipeline security best practices. I hope you enjoy this new episode. Now let's dive in.
Today with us, we have Adib Saikali. Adib, thank you so much for joining us.
Thanks for having me. So my name is Adib Saikali. I'm a principal solutions engineer with VMware Tanzu. Essentially, what I do is I'm a code janitor. That means I spend a lot of time working with Kubernetes, Cloud Foundry. I mostly come from a Java developer background. So that's what I do. I'm also writing a book for Manning called Securing Cloud Applications. Over the years, I've been involved in building kind of RBAC security into various applications that I've worked on. So I've had to learn a lot, and a lot of the books I went through were very much written by security people for security people. So this book kind of represents the thing I wish I had when I started learning about security years ago.
CI pipelines connected with security. I'm sure that over the years you have seen many patterns and anti-patterns, how to do things right and not right. Can you speak a bit more about that?
So let's talk about some of the kind of challenges I've seen. So I've seen this a lot with customer code bases where they'll have an enterprise application that they built and it's integrated into some sort of enterprise security system. Like maybe you're online banking and you need to type in you want to log into the bank's online banking. You need the bank card number and a password, and then they call the mainframe, right, to find out if you're allowed to log in. Or it could be that you're they go against Active Directory very commonly, or maybe it's a more modern setup with OpenID Connect or SAML. But one of the challenges that I've seen dev teams run into is, okay, I check out the code onto my laptop, and now I want to run it, and I don't have it hooked up into the real security system. So sometimes they'll kind of have like a dev mode of the application where they can log in with a well-known user set, maybe user Jim is a customer and Bill is a tech support agent that's in a call center helping them out, and they're trying to do things. That's, I think, is one of the challenges I've seen. And it's pretty annoying because I know two teams do it the same way. And so whenever you look at the code bases in these teams, it's like, how do we do this? Like, what are the unique ways of configuring security? The other aspect of it is it's related to writing tests, right? So say I want to write an integration test or a unit test that requires me to know the identity of the user. These types of complex permissioning workflow type things, they're very much tied to security. And this is where I see those kinds of systems. I don't know if you ran into that with your own application, how much permissioning context you have.
In the latest iteration of our application, that's somehow pulled aside. So it's not the core part, but yeah, historically it was very much a part. And, just running integration tests of like checkout process and, subscriptions, annual, monthly, all of that. There was always those adapters and layer, how much you mock or fake or you connect to the real system or not is always a question what to do. Yeah.
That complexity is inherent in that. So I want to talk about a couple of patterns that can really, I think, help with this. Those patterns basically are something we have access to today that we didn't really have access to in the past, which is OpenID Connect. So the first thing to think about is that the first kind of best practice is to figure out when your authorization logic or security logic is actually business logic. It is not something you kind of hide away in a separate product. How can you make it simple? So the key protocol from my point of view is OpenID Connect because it allows us to define backend APIs, which are stateless. The backend logic is where you're absolutely going to enforce security as close to the data as you can. And that means that you need to know who's actually on the other side that's making a request. But also what we typically find on the back end is that we want to have horizontally scalable logic, right? We want to be able to take our application and we want to be able to run, one instance, two instances, three instances. Ideally, you are following 12-factor, which means those backend APIs should be stateless on their own. Any state is stored in an external service like a database or something like that. So the cool thing about OpenID Connect is that we can write resource servers where we basically say, when you call us, we expect you to have a JOT token that comes in as a bearer token, and that's going to have a certain set of scopes, a certain audience, and that will allow us to know step one is write a resource server. and don't have that resource service know anything about how to log users in. It doesn't know. It just says, if you don't have an OpenID Connect token that's currently valid with the right things, I'm just going to return 403 unauthorized, 401 unauthorized. I forget if it's. The other side of it is, well, what do you do on the place where people have who knows who the user, who handles the login? The answer is you should pretty much at this point dedicate that to an OpenID Connect server of some kind. So if you have a single page application, the user lands on your single page app and they click the login link, you should redirect them to the login server. There's two patterns there that I see, and one of them is people will do client-side login, say for example with Angular or React. And that means that your interaction with the OpenID Connect server is happening directly from the browser, from your Angular code to the OpenID Connect server and back, and you get a token, and then you forward that JOT token to the backend resource server. However, I don't recommend you do that. The reason why is that the better way to do it is to, in fact, delegate that access, that authentication to some sort of API gateway that's in front of your stateless backend resource servers. And so what that interaction would look like, your client, be it, a native app or a single page app or just a regular server-side rendered web app, you just send an HTTP redirect to the login server. Login server displays a standard login screen. User logs in, and the HTTP session is established with the API gateway. Once you've established that with the API gateway, you can typically run several instances, do HTTP session replication, track who it is. From a security perspective, on the client side, it's simple. Just remember the HTTP session ID. And on the server side, your API gateway can forward and relay the token, like who the identity of the user to the backend services, or you can do some sort of more advanced routing logic, more advanced kind of server side. Oh, this user has this role. So what I'm going to do is I'm going to consult some sort of entitlement server or a place where I keep what users are allowed to do. I'm going to mint a new JOT token that actually very precisely says what the scopes are that they're allowed to do or not do, and then forward it along. So you've got your API gateway. You check if the user is not logged in. You have your replicated HTTP session. You forward requests to the backing services that are part of what the front end needs, and life is simpler. The other thing pattern that I've done with that is on the front end UI, you tend, when you kind of initialize your single page app or whatnot, you kind of send back an array of what are the features that the user is allowed or not allowed to do. So at login time, you can kind of go through and say, okay, Adib is logged in. What are all the permissions what are all the roles that Adib has? What are all the permissions? And then I tended to boil it down to a matrix that boiled down to, can you perform an operation or not? So this would be like a feature flag, a features array that gets sent to the client. And then in the UI code, you're like, hey, should I display the edit button or not? And so that's one part of it. Now comes the part of okay, what do I do on my laptop? The advantage of this type of approach is you can easily run an OpenID Connect server directly on your laptop. So being a Java Spring developer, I tend to rely on Java tools. So my kind of go-tools there are the Spring Cloud Gateway, which is an open source project based on Netty and non-blocking IO. So even if you're not a Java developer and you're looking for a super scalable open source API gateway, I would recommend you take a look at the Spring Cloud Gateway for that reason. It has the ability, if you add a bunch of the other things from the Spring ecosystem, like Spring Web Session, you're going to get a free replicated HTTP session. You can put it in Redis, Postgres, whatever you happen to want to do. And then it's got that ability to do token relays down the line or token exchanges, all the typical patterns. So once you have that, then your experience as a developer on your laptop is you launch your local API gateway with the OpenID Connect server running locally, and then you can now actually do development the same exact way that would be in production, except that you can program the OpenID Connect server to have your standardized set of users to test different scenarios. And then to kind of take it a step further, one of the tricks I've used in writing tests, because that's the thing I ultimately want to do. I want to be able to know I can run enough tests on my CI that I feel confident that I can go to production, which means I need to test all the security features. I've ended up creating little helper libraries that I would call stock users, as in, get it off the shelf. And I would give those users names. So Jim would be a user who is maybe a follower of the company, whereas Linda might be a member of the board of directors and somebody. So these become kind of users that people know about when they write tests, which have certain permissions and all this type of stuff. Then what happens is that it goes something like this. I build, in the case of Java developer, I write Java classes, build a little DSL to represent those things. And then I'm able to, in my test, kind of set up a particular scenario. Like I'm uploading a new document. This document is tagged for permissions with only advisors can see it. And then I can do a bunch of things. Take the stock user, Jim, who is an advisor, log him in and check that he can see it. Take the user, George, who's just a follower of the company, and check that they can't see it. So you're able to now write validation test logic to validate that everything works, and you lower the cost of writing a test.
Microservices architecture is all the rage these days. But do you know what it really means and how to implement it to empower your teams to make the best decision for the problem at hand? On the Semaphore blog, you can learn about microservices and how to take advantage of features like test reports, monorepo, and Docker support to build, test, and deploy your microservice application at scale. Head over to semaphoreCI.com/blog for more information. And happy reading!
Obviously, over the years, people come and go in the team and test suits grow. How you do distribute that knowledge across the team and so on? Any tips, perhaps?
What I tend to do is I tend to kind of create what's called test fixture projects. If I have a project, call it document management in this application, then I would have an associated project called document management test fixtures. And the test fixtures are classes in code that you use when you're writing a test. And the idea is to make all the tests simpler to write by having them all leverage common helper classes. Something like the stock users service is going to be, in my case, because I code in Java, it'll be a Java package, potentially be its own jar file. It'll absolutely have Java docs attached to it. So internally, it is a common code library that people can use, just like they would use an internal utility library to, talk to the database or call a payments API or something like that. Putting these test fixtures alongside in each project. So each project has 3 types of source code in it. One type of source code is the actual code of the project. One type of code is the test fixture code. And one type of code is the actual tests. And so your test code is allowed to depend on the actual application code because you need to test it. It's also dependent on the test fixtures code. The test fixtures code for me is, in my experience in the past few projects, it was a lot more trickier to write the test fixture code than was to actually write the business logic. The reason why was that you had to deal with these situations of like, how do I set up the right security context so I can actually make a meaningful test? How do I get dependencies like the database or the application? Or how do I get a test where I'm simulating an error condition? Like how often is S3 down? Well, never. Until it's down, and then the whole internet breaks, right? So how do you know that your code will work? So you need to be able to create things where you can produce these test errors that are hard to reproduce. This is the kind of infrastructure you need to make writing tests easier. This is the test fixture infrastructure. Security is part of it. Dealing with time and clocks is another part. And the third part is dealing with databases. Because a lot of the time our state is stored in some sort of database, and depending on what's in the database, your test may pass or it may fail. So the way I deal with the database is I use a project called test containers. The basic idea behind it is pretty simple. I write a test in JUnit, for example, in Java World. And when I run my test, what I'd like to see happen is I'd like to be able to say that this test requires a Postgres database and a Kafka message broker. Okay. In your configuration, you specify the version of Postgres, you specify which container image has this. So what will happen is when the JUnit runs, before it runs your unit test, it will go and it will spin up a Postgres database in a container. It'll go and spin up a Kafka in a container. Because you spun them up, for the purpose of that test, you know exactly what state they're in. You know exactly that say, for example, your database is empty or your database has a starter data set in it and what's on your Kafka topics. And then what you can do is you can put your database and your Kafka in a well-known state and then run your test. At the end of the test, because they're containers, it'll just blow them away. It'll just throw away the container. The next test that runs is going to start brand new containers.
You probably contributed to leveling up the security culture of a teams and a maturity level in that aspect. If you can, share some of your thoughts in that area.
Security is not that hard, okay? if you approach it correctly as a developer. And what I mean by correctly is you need to separate what you need to know from what you don't need to know. Unfortunately, a lot of security books tend to be written with the assumption that it's being read by a security professional. I kind of break down what a developer needs to know into a few areas. One is you need to understand the basics of cryptography. What's a hash function? What's a cryptographically secure hash function? What is public key cryptography? What is when you encrypt things with symmetric key cryptography like the AES? What are the parameters that you can use to tune it? In most places, InfoSec teams will have please use this combination of things. And you want to just understand enough to know what's the right way to configure the industry standard blocks in your programming language. So that's step one. Number two is you want to totally understand digital certificates. X509 certificates are super important to understand because they are used everywhere. The next thing, once you know that, then focus on understanding TLS, because TLS is everywhere and we should be doing mutual TLS everywhere with whichever way we do it. So once you wrap your head around those and you've up-leveled on the basics, then the next step is to start looking at two types of problems. One is, how do users log in? Since it's 2022, just focus on learning OpenID Connect. That's it. This is a protocol. You learn OpenID Connect. You can use it with all programming languages. The other protocol you want to pay attention to is something called web authentication, WebAuthn. But this is how you can actually log in without a password. So once you know those two things, then the next problem that you have, how do you secure the call chain? This is where you have your service A, called service B, called service C, and it's very tricky. There isn't really an industry standard way to do it. So you have to learn the various patterns for doing that. You might use API gateways, you might use a service mesh, you might use other things to kind of solve this, but there's a bunch of basic patterns that you can learn. And then the last area is more around how you manage credentials securely. How do you configure all the Kubernetes security features? How do you containerize your code securely? How do you put your credentials in a credentials vault?
And in the realm of pure build and test CI pipeline, to be super specific, I know that we have various tools in place. This really depends on the technology stack that you are using. Something that verifies all your dependencies. Then does some linting on the code, what can be figured out, maybe on the level of framework that someone is not applying. Just certain calls that must happen and so on. So that very, very practical level of maintaining that piece of a pipeline. Anything you can share in that realm?
So the key thing there is, I think, pay attention to some of the emerging standards like SALSA and what that means. You absolutely need to have a 100% reproducible build. You absolutely need a way to manage your dependencies in a centralized way and, kind of create a proper software bill of materials. So there are a lot of tools in that space, and it's, I think, going to take our industry probably another 5 to 10 years for that to really
inspiring
be widely available. So I'll shorten it to, if you don't have a lot of time and you're running code in containers, go take a look at a project called buildpacks.io. It's part of the Cloud Native Computing Foundation. That's a really good way for you to leverage the best practices of the industry, because those, for example, when you containerize your code with buildpacks, is going to generate the software bill of materials in SIFT and in Cyclone DX. So you'll be able to start following best practices. So that one is a bit of a Wild West. Go try out everything, learn everything, and stay on the bleeding edge, because that's where the industry is heading.
Yeah.
And I think that's an area for folks like yourself at Semaphore to actually help your customers kind of get that out of the box, right?
Yeah. Tell us more about the book, how the process is going.
In terms of date, I would say as soon as possible. I'm focusing on finishing this up by March. In terms of the structure of the book, it follows what we talked about. Teaches you the crypto fundamentals, teaches you what you need to know about TLS, then teaches you what you need to know about logging users in, then switches focus to securing the call chain and how to run things securely on Kubernetes.
Very practical.
Yeah, one of the key things in the book is there are no equations, there's no math anywhere, but there are a lot of sample applications. And the idea is to help developers understand security by running a sample app that lets them see the security protocols in action. So they go oh, I understand what's going on here.
For people that, want to follow you and learn more about you and your work, can you give us some, pointers?
Yeah. So I'm at ASAIKALI, Saikali on Twitter. You can also find me on LinkedIn And I do maintain a personal website, adibsaikali.com, which I have on my to-do list on my whiteboard to improve the look and feel for the last 2 years. I tend to, there's a whole bunch of stuff on YouTube that you can find, like talks I've done. Most of our conferences quite frequently. I tend to hang out in the Java universe. So if you're not in the Java universe, you're absolutely welcome to chat.
Thank you again. And good luck with the book.
Thank you very much. Have a wonderful day.
What a great conversation. We hope you enjoyed it and learned something new. Make sure to subscribe to Semaphore Uncut on your podcast player of choice so that you don't miss our new episodes. And stay tuned.